Okay, so let's move on to this. Okay. All right, so let's continue the lecture today. So yeah, so last time we activities the points. Uh, so we are trying to show that uh, uh, yeah, so here we have the uh, so this is uh check this the y, and then so here is the v naught, and then from v naught to the uh, v naught plus one. So this is the small divided to that. Okay. And then so this exponential left. And then map. And then so here yeah, then yeah. So okay, so then we get a loop here. Um I think it's the other way, right? Yeah, so it's this okay. Um okay. Uh so this is in Taiwan, right? So so we are trying to show that uh Taiwan of C star separate zero now is the infinite uh, uh C cube generated by gamma at zero now. 这个 gamma at zero now. So uh so uh okay. Okay, so that is we have the reading gamma at uh, zero dot is mapped to one under the yeah actually let me just do this. So it's mapped to one under the collision of the isomorphism gamma to z uh given by phi maps to phi 知道我知道 and the isomorphism isomorphism from Taiwan to uh, x theta dot. Right? 谁？嗯
Hello，Hello，你这有没有空的网线借我用一下？
没有，
哦，你在录视频？
对对对对对，
哦，打扰你了，OK。
我这没有这么事情。
哦，我借一根智能电话线，我的那个电脑需要更新，但是我的 WiFi 断了，我拔下来我就继续。这样，我就换自己。OK。
So Taiwan now uh yeah sorry I'm gonna might come to borrow a uh wire transfer. Yeah. Um so and as movie some uh Taiwan XX sorry Taiwan X now. Yeah. To the deck translation. Yeah. Yeah. So given by yeah, so this just uh yeah, so you have the fundamental book, right? And then yeah, on the yeah, on the adaptation map. Okay, on the fundamental book and the dash transformation book. So given by uh okay. So yeah, so given by the standard maps, the different class of alpha certain idea now, which goes to the like phi. Yeah. So where this where we have the phi of uh, is equal to yeah alpha tuna at one or the alpha tuna uh t of alpha with alpha tuna zero equal to zero. Okay. Uh, yeah. So okay. So uh, okay. Yeah. So this isomorphism, I think uh uh yeah we just chose this isomorphism, right? So we show that there is a uh bijection between the z, yeah, a bijection, and then yeah, yeah. So and then also uh okay. Oh, okay, okay, I see. Um, yeah. So I think here, yeah, okay, yeah. So yeah. So previously we show that this n goes to phi of n goes to the map c plus n is a homomorphism, right, from z to uh the back. So we need to wait. Yeah. Okay. Yeah. Uh, and then so and then it's for the backward mapping, right? So how do I get the n? So basically, yeah. So like,哦，哎，它的气干性做一些 cover space 一些
你这么晚了不回去？
性，就是你什么，不当然，yeah, we are the people. Yeah, so I think the way to derive this n basically is that you plug in like a z naught here, right? So yeah, so yeah, and then you subtract the z naught, then you get n. Okay, yeah, and then I suppose, and then I suppose yeah. So when you have isomorism, oh, okay, yeah. So when you start the element, okay, when you start with the element here, okay, you start with a um okay. So yeah, so this map, right? So this map, I uh yeah. So imagine that this alpha is like the little gamma, right? And then goes to the map phi, where so you replace. So just imagine that you replace the this alpha, okay, uh, just by this little gamma, okay. So so then uh okay, so then this amplitude is the lifting of this, yeah. So yeah, by the unique lifting theorem, then this lifting is exactly the gamma tutor. Okay, yeah. Uh, okay, we are found still not. Oh, uh, file of still not. Okay. Mhm. Okay. Mhm. Think here you need to apply some trick here, right? So I think like the original definition for this one is uh the file of any point, right? So it's the image of okay. So wait, okay. So what is the what is the actual image of this functional group? So basically, the idea is that if you take any so okay, so you map this element of this alphas in the fundamental group to the element phi in the determination group, given by the phi of any value is being mapped to so basically here we construct like a path from this to z, and the phi of any z, right? Because this phi is like a homomorphism, right? So wait, yeah, yeah, it is a homomorphism, and then we consider any path, and then you uh you do a projection, and then you do the unique lifting of the path, okay, and then yeah, uh okay, so here, wait, yeah, that transformation, okay. Okay, so yeah, so here what we do is that we we just do the constant loop. So um, and then if you yeah, that will be the constant loop here, and then yeah, it will be the constant wait, right? The lifting of constant loop. Yeah, the lifting of yeah, so the lifting of constant loop must so why is the lifting of the constant loop must be constant okay. Okay, I think that's by a connected argument here. Okay, because yeah, because the image, so because the lifting must lies in one of the discrete set, right, which are disjoint. Yeah, so otherwise you will get a separation. Okay, okay, so yeah, so then it must lies here. Okay, so yeah, so therefore it is exactly this point. Wait, uh, I was confused. So. What does this? Yeah, 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 yeah. So we are focusing on the files now. Okay, I see. Uh, okay. So, uh, okay. So, okay. So now what do we have? So, okay. So we have the. Okay. So first we start with. Okay. So let's call this. Uh, call car. So, and then let's call this one F. Okay. So then you may have uh F components car, right? So where of this path gamma uh, zero naught. Okay, so which is equal to oh yeah, because uh Yeah, because it's still a null, right? Uh, it is given by the projection of, yeah. So this small gamma is given by the projection of this gamma tilde. So therefore, we will do the lifting. Yeah. So endpoint actually wait. Uh, yeah, actually, by the argument I just said, right? So the meeting of the constant loop will give you that. Okay. So uh, yeah. So therefore, uh, yeah. So therefore, you get this map. Okay. Phi of this out goes to alpha tilde of one, where this alpha tilde is exactly the uh gamma tilde one, which is zeta plus one, and then take the difference. Uh, that give you one. Okay. Okay. Yeah. So this is being shown. Okay. So okay. So okay. Yeah. The scooter is like yeah. Okay. So now we have any proper subgroup. Yeah. So proper subgroup basically just as uh, a subgroup that's strictly contained in the Z. Okay. As gamma of Z. Yeah, strictly contained in the in this group V, which is isomorphic to the back transformation group of this gamma, which is isomorphic to the pi one of C star, with center at the node, must be of the form E of form uh gamma, which is equal to mv. Yes, for some okay positive. Okay. So that is yeah because any subgroup of Z, okay, because it's a subgroup, right? So it's also a uh so yeah, I think by by the result of group theory, this is true. Okay. So and then okay, so uh that is gamma is infinite cyclic subgroup under sorry generated by uh generated by this gamma of the M power. Oh, okay. Z naught. Okay. Zero dot. Okay. Yeah. Okay. So we're um yeah. So here I think the what's going on is that you wrap around M times. Okay. So we wrap around M like times. Then you get a map from Z naught to Z naught plus M. Okay. Uh yeah. Okay. Uh so then okay, so then uh we have a homomorphic transforming map universal Fourier map. Yeah, so okay, so it's gamma of is gamma from C to C star given by um okay, so V that's to e to the 2 by I Z over F. In fact, we have gamma. So gamma is the combination of the morphic universal covering map uh C to C star given by yeah, so this is the previous map. E to the 2 pi Z. Sorry, Z to the Z. Sorry, E. Uh Z to the E. Sorry, Z to the E of 2 pi Z. Okay. And uh by homomorphism from C to C by given by the map Z maps to V over N. Okay. Uh, yeah. So wait, this 1 to 1 and on to yeah, it's definitely onto, right? And Y is 1 to so okay, so let's call this map phi. So suppose that you have a phi of T1 equal to phi. Oh, okay, yeah. Uh, yeah. So you just multiply by m. I think yeah, these are the same point. Okay. So and then yeah, yeah. Okay. Uh, okay. Yeah. Then you define the inverse map to be the homomorphism. Z maps to and yeah. Okay. So why we have the homomorphic uniformity map? Given by this one. Oh, mm, oh. I think you have the quotient. Uh, okay. So here, okay. So yeah. So this group is uh isomorphic to the set of all phi in the deck transformation group where phi of v naught equals to um v naught plus m z, right? Okay. So uh okay, so this should be the quotient map, I think. By C. Okay, so yeah, I think this is a quotient map. So if you quotient out uh okay, so why it's doing like that? Because okay, so because if you quotient by uh wait, wait. It's a composition of homomorphic uniform map. Okay. And the biohomomorphism. Okay, so think that's the same. Uh, yeah. So same as the uh quotient space. Okay. So let's say that we have C and then you quotient by um the equivalence relation um where Z is uh so where Z is equivalent to Z prime equal to the prime is equal to the plus uh KN. So okay, so let's see what is this back. Okay, so what is this back? Uh, yeah, so namely, if you have um, wait, okay, so let's see if you have if you input it as x plus y, right? Then it goes to e to the um I x plus y everything over n. Uh, angle is shaped by n, right? Yes. So then um okay. Uh wait. No. So so you have the okay. So you have the gamma. So didn't know, right? Mm, oh, so okay. So here it has an angle. So x is the angle, and y is the distance, right? So the distance is kind of like uh the scale, but the angle is like uh okay. Yeah. So the angle is like uh so imagine that yeah. Uh so yeah. So for the yeah. So okay. For the angle, basically what you do is that it start with it down, right? And then you have to so for it to be in uh okay, so for the angle, okay, so for the angle, in order to reach a for loop, you need to add. add to the x to get the same. Okay. So therefore, the x is identified by so any. Okay. Yes. Any z is being wait. Oh, yes. Okay. So any z. Okay. So basically, if you change, okay. So if you keep the y value being fixed, okay. So then for the x value you add it by add, you get the same number here. Okay. So that's the reason why this is the same thing as you quotient out by the that relation. Okay. Okay. Uh, okay. Oh, uh, yeah. So these are so those uh oh yeah, yeah, okay. I think uh okay. So if that I'm not sure if that is enough to conclude that these two are the same mapping, right? So okay, so on the one hand, this is a quotient, and then this is actually um, so why they are same relation? Why they give um, okay, uh, okay. Think under the um uh I think it's under a sequence relation. Yeah, so I think you have to somehow identify the quotients by thing. Okay. Oh, yeah. So if you have the zero is mapped to um so if you have zero here, then it's mapped to e to the two pi I. Okay. Zero angle and also the one. Okay. Okay. So um okay. So yeah. Yeah. Next time we'll just start with here. Oh, yeah. So why is a harmonic universal coming back? Okay. Yeah. So we'll start by checking it is uh it's definitely a universal common. So the space is definitely simply connected and also uh yeah and also it satisfies is a common map. Yeah. So why is a common map? Uh okay. So okay. Yeah, we will show that why it's a common map. Yeah, it's yeah, it's homomorphic. Yeah. Okay.